It's like this. Air pressure is always pushing on us from all sides, about 15 pounds of pressure for every square inch. But at the same time, our bodies push back against the air pressure with equal force, so it balances out and we don't get crushed.
I wish I could see all this.
Well, think of it this way. Picture air molecules near the ground as being packed tightly together by the weight of the air above. This is why air is much denser at sea level. But higher up in the atmosphere, there's a lot less air pushing down from above, so the air molecules are not packed together so tightly. Normally, we don't feel any of this unless the pressure changes suddenly.
You mean like when your ears pop in an airplane?
Exactly. At much greater heights, there is less air weight pressing on you. Your body is reacting to the pressure change.
Scientists use barometers and other tools to study the air pressure, to predict the weather, and to study climates. You can measure changes in air pressure too. First, we can do an easy experiment to see how air expands as it gets warmer. Take a balloon, blow it up slightly, and attach to the top of an empty soda or water bottle. The larger the better. Put the bottle in a freezer. Meanwhile, get a sink or tub of very warm water ready. After 10 minutes, take the bottle out of the freezer. Observe the size of the balloon. Quickly submerge most of the bottle under the very warm water. Hold it in the water for at least 30 seconds. Observe the size of the balloon now. This is because the air inside the balloon is warming up and expanding, just as warm air in the atmosphere expands, gets lighter, rises, and creates a...
This is a dish filled with mercury. Mercury is a liquid metal, and you can see that the dish is open to the air right now. And in the dish we have this tube that's also filled with mercury. The tube is open at the bottom and it's immersed in the dish, but it's closed at the top. And so you can see that the mercury inside the tube is not going down at all. It's kind of the same idea if you've ever put your finger on top of a straw. The liquid stays in there. Okay, now if you can imagine this, remember all that weight that we have from the air? So that weight is going to be pushing down on the mercury in the dish. And that's kind of what is holding this mercury in the dish at a constant level. It's also going to hold the dish, or the mercury inside the column, at a constant level. Now here's the thing with atmospheric pressure. It changes all the time. Sometimes it may push down even more, and if it does, the mercury in the dish has to go somewhere. The only place it could go is up the column, and so this would be pressure going up, or high pressure. And if there's less pressure, less weight pushing down, then we'd have low pressure. This allows us to predict the weather. High pressure means we're going to have nice, sunny weather. Whereas a low pressure, if pressure is falling, means it's going to be rainy and cloudy. And that's how a barometer works.